Hello, myself Ravindra Chavan, Assistant Professor, Department of Electronics Engineering, Walchand Institute of Technology, Solapur. In this session, we will discuss the various arithmetic instructions defined for the microcontroller 8051. So after this session, the students will be able to develop the 8051 based systems by writing the various assembly programs. So in this session, we will discuss the arithmetic instructions and then we will do some exercise. So arithmetic instructions are used to perform the various arithmetic operations like addition, subtraction, multiplication and division. So add C, sub B, INC, DEC, mul AB, div AB, da. These are the various arithmetic instructions defined for the 8051 microcontroller. So we will start with the first instruction that is used to be for addition, that is add instruction. And syntax for add instruction is add a comma operand. So for all these arithmetic operations, your destination operand always be a register A, that is the accumulator, and the source or the second operand can be specified in different manner. So this add instruction adds the operand value into value stored in the register A, and after addition it stores the result in accumulator itself. So operand value does not change. It has a different forms like add a comma, we can write the immediate value. For example, add a comma hash 50h, or second value can be specified by writing its memory address, which is called the direct addressing mode, or we can write the second operand in one of the 8051 register and we can specify that value by writing the register, say add a comma r0. This add instruction, it always also supports the indirect addressing mode, and this add a comma at the rate dptr, this is to be used to access the data from external data memory. So example, add a comma 05, this instruction adds 05 into a value in register A and the result will be stored in the register A itself. Another way of specifying the second value by writing its address. So 30 is the address of the data to be added in the register A. It also supports the indirect addressing mode. So R0 register holds the address of the data. Add a comma R1. So the one value is in the register A and the second value is in the register R1. Destination operand, it must be always a register A. Add instruction affects the carry flag, auxiliary flag, parity flag and overflow flag from the PSW register. Show how the flag register is affected by the following instruction. Move a comma hash 0 F5, means the value is F5. Add a comma 0BH. So pause the video and you, after executing these two instructions, you just write the status of all these flags. So F5 plus 0B is equal to 0 0 0 0 0 and carry is generated. That's why carry is 1, since there is a carry out from bit D7. Parity flag will be 0 because the number of ones are 0 and even number. Auxiliary carry flag is 1 since there is a carry from D3 to D4 bit. Add C instruction. This instruction adds the operand value, and into that it adds the status of the carry bit. So adds the operand value along with the carry bit into a value in A and store the result in the register A. So example, add C A comma hash 06H. So the new value in the register A will be A plus 06 plus CY. If CY is 0, that is the carry bit is 0, then 0 will be added. If carry bit is already set, that is 1, then 1 will be added into A plus 06. Similar to add instruction, it also supports the various addressing modes like immediate, direct addressing mode, register addressing mode, indirect addressing modes. Sub B, which is called subtract with borrow. So subtract operand value with the carry bit from the accumulator. So the second operand, it is always gets subtracted from the accumulator. So example is sub B A comma hash 05. So the operation will take place like this. First 05 will be get subtracted from A, and then the carry bit will get subtracted. It also supports the various addressing mode, direct addressing mode, that is sub A comma 30H. Then the second example is for the indirect addressing mode, sub A comma at the rate R0. Then it also supports the register addressing mode. Next instruction is the increment instruction, and the mnemonics is INC. So it increments the operand value by 1. So only one operand is required, and this instruction supports the direct addressing mode, register addressing mode, indirect addressing mode, and mostly required to increment the counter whatever we are using in the loops. So format for increment instruction is INCA. So value stored in register A will be gets incremented by 1. INC R7, INC 40H means the actual value is at the memory address 40H, and that value will be incremented and written at the same address. INC at the rate R0. So this is the indirect addressing mode. So INC hash 05, this is illegal operation because we cannot increment the value by 1 which is written in the instruction itself. So it does not support the immediate addressing mode. Similarly, for decrement the value by 1, the DEC instruction is provided. So again only one operand is required. So it supports the direct addressing mode, register addressing mode, indirect addressing mode, and this is again mostly used along with the loop counter. So these are the different formats for decrement instruction. Again it not supporting the immediate addressing mode. Mul AB, this instruction is used for the multiplication, and multiplication is done only with the value in A and value in B, and the result is stored in the register B and A. So the after executing this multiplication operation, the B register holds the higher byte and the A register holds the lower byte. Similarly, the division operation div AB, this is the only one format for the div instruction, and it always divides the accumulator by register B. Okay, so after division operations, numerator for division operation, numerator is in the register A, B register contains the denominator, and after execution of this div instruction, the quotient will come in the register A and the remainder will stored in the register B. Da instruction, it is used for decimal adjust for addition. The da instruction is provided to correct the problem associated with the BCD addition. The da instruction will add 6 to the lower nibble or in the higher nibble of the result when the digit of result is greater than 9 or auxiliary carry flag is set. So this is the example of da instruction. So here after addition, value is coming in the register A is 6C, but for BCD addition we need the output in the BCD format. So in the 6C, in the C it will add the 06 and we are getting the expected result as a 72 after adding 47 and 25. So write the 8051 assembly program to add two values stored in internal data memory and store the result in the memory itself. So pause the video and write the instruction for this. So solution for this, move A, 30H, load the register A with the first value, then add the second value in the value stored in register A, then move 50H, A, so store the sum at the address 50H. The same can be done by using the other addressing mode like the register addressing mode or register indirect addressing mode. So references, the 8051 and embedded programming by Majidi and microcontrollers by Ajay Deshmukh. Thank you.